Hello, everyone. We keep discussing the EV battery manufacturing. In this episode, we will focus on energy consumption monitoring and management. So, Lucas, hello again, and let me pick your brain a little more on the topic of EV batteries. So, in our live podcast, we discussed in detail the problem of energy management. We mentioned that you need a proper management system in order to reduce consumption, which is these days extremely important. But then again, it is also related to reducing carbon emissions. So I am pretty sure that this problem is also valid for EV battery manufacturing, but I assume this particular industry has its own problems and own considerations. So could you tell us what is the main point regarding energy management in EV battery manufacturing?
Hello again, Piotr, and thank you for this question. So I was talking before about the OPEX, and I believe that when you consider energy and OPEX, this is completely matching each other, because it's important for us that you are able to track where you consume your energy when you manufacture your packs and modules. So what we intend to do is to have what we call energy per unit. So you are able at the end to tell that with this module or with this pack, you consumed this amount of energy. And then you can easily compare why this was here, why it was more important, why it was less important, etc. And in this way, you can, having those information, work on it and improve and again reduce this energy you consume to manufacture your modules and packs.
When you say energy per unit, the unit is the module, the cell, or the pack?
Good question, good point. In our case, we are talking about the modules and the packs. So having this information on module and pack is fine, important, but it's even more important to have this real-time information. Because when you see that something is going wrong, then you can act immediately also. So to have an impact and stop that if something is going wrong, not to wait that it's too late. So this is always important to have this energy per unit, module and pack, and also real-time information. So you can again act as quickly as possible.
Mm-hmm. So we are discussing energy management. In case of EV battery assembly, what is the key aspect to manage energy well?
Having this data of energy we consume in real time is the first step. The second step will be that, as I mentioned, you need to see what is happening. So you should be able to compare the different information and so on. Having this kind of information, you can then apply some intelligence on that. We can talk about artificial intelligence, statistical methods, etc., to extract, some calculation, create insights for your maintenance manager, production manager, general manager, etc. So you can adapt what you see to the level of management in the company, and then everyone can act where it's necessary. As a next step, after you make this calculation analysis, ideal approach would be to act automatically when something is going wrong. I can give you one example. We have developed a technology that takes into account from the previous year the temperature, humidity, basically weather forecast from the past year, and also you take into account the future elements, okay? We take into account also electricity that has been consumed. We put that all together, and with our technologies like MyLab, we can estimate what would be the energy consumed in the future. Thanks to this technology, you can have what we call self-adaptive system, because when you know that at a certain moment you will consume more energy, you can simply reduce your production or simply stop it if it's really too high. But when the cost is much lower, then you can increase your production. So you can still have like a same level or reaching, the stable cost of energy and the lowest as possible to ensure that you manage correctly the cost of manufacturing of your battery modules and packs.
Can this adaptation be really done automatically these days?
Currently, with our technologies, it can be fully automated. So starting from the data extraction, analysis, visualization, processing, and sending feedback to the machine. So this is fully integrated. So we have some experiences that some of our customers accept this idea to have, machines that are taking decisions on their behalf, acting when it's necessary. But on the opposite, you also have some still customers that do not really accept that the machine will take such decision on their behalf. They want to have a process engineer that read this information before giving the authorization to this solution to implement it and to make this correction by itself. You have two approaches, but our technologies allow us to do the second one. So to have a fully integrated, closed loop when it comes to collection of data and making necessary modification in the manufacturing line.
So let's keep the topic of whether this is fully automatic or there is some central maybe team of experts who is taking decisions whether to stop or continue the production. Do you think that this self-adaptation of manufacturing systems is the answer to the rising energy crisis?
So having the possibility to self-adapt the manufacturing to the energy cost is one of the possibility how you can immediately reduce your manufacturing cost. It's not the only one, but it's one because it can be immediately implemented and it can act on your behalf. So you don't even not to dedicate a person to look after that. Mm-hmm. It can be, as I said, fully automated. But yes, this is definitely one way how you can reduce this cost.
To sum it up a little bit, so it seems like if we are able to correctly analyze the data, we can have measurements such as energy per unit, and this gives us the full visibility of the battery manufacturing. And then we can use these self-adaptive technologies to reduce the energy consumption and respond to the energy problems. I think that is the conclusion of this conversation, right?
This is perfectly correct. I would add just one thing about the real-time data analysis. So to have the really on-time, so real-time data along this process. Mm-hmm. So not making, analysis afterwards, but really real-time.
Thank you very much. Very interesting stuff.
Thank you, Piotr.